All right, now problem 38, page 657. You have problem 32 that I sure hope is like this one. I got to tell you, I can see through this one right now. This is pretty easy. I hope you've got something just as easy. This says I've got vertices at plus or minus 5, 0, and I've got a focal length of 2. So find the equation, draw the graph. So whatever should we do? Let's plot some points to start off here, right? Let's draw us a graph. And I've got a vertex right there at 5, 0. And I've got another vertex right here at minus 5, 0. So that's just a little bit of information, but it's actually a lot because it tells us there's an ellipse here, right? And moreover, that ellipse is centered at 0, 0 by symmetry, right? I'm 5 this way, I'm 5 that way. The ellipse is got a center right there on this major axis, and what's left for us to do is find the minor diameter, and you know, it might look like this ellipse that we're after. Now, we don't know B, so heck, it might look like, not like that, it might look like this. Right? We don't really know who the major diameter and the minor diameter is. We know that the x-axis contains one of those two things. So all I've got to do is make use of this information right here, because it says there's a focal point right here. That focal point has a focal length, the distance from the center to the focus. Focal length is the distance of the center to a focus. Okay. And so this point is the point 2, 0. There's another one over here, which is minus 2, 0. And all we've got to do is find this quantity. We're going to call this is A, this is B, that is C. We're looking for B, so by the Pythagorean theorem, A squared minus C squared is going to be equal to B squared. We've got A is equal to 5, because A gives 2A is the length of this major diameter, or this diameter, and so 0, the center to this vertex is the distance A, and that's 5, right? Right, yeah. So I've got 5 squared minus C. We were given C as 2, so 2 squared is 2 squared. And here comes B. So I've got 25 minus 4, feeling like I'm going wrong here somehow, is equal to 21 is equal to B squared, so B is equal to root 21. And that puts this point up here. It's actually root 21. Yeah, no, it's actually this way. This point is the point 0, root 21. And this point right here is 0 minus root 21. Okay, so I've got B is equal to root 21. I've got A is equal to 5. So the formula here is x squared minus h is 0, all over a squared, I'm just going to make it a 25, plus y squared minus 0, k is 0, all over b squared, 21, is equal to 1. And there's the equation and the graph that results from this data. Okay, let's move on.